Hello guys, welcome to this very first tutorial of this project. This project is built on Python programming language. Python programming language is a high-level interpreted programming language that's easy to learn and to use. It's widely used for a variety of applications, including web application. Django is a popular web framework that's built on Python, and it's designed to make it easy for developers to build and maintain web applications quickly and efficiently. Django itself is built on the model view template architecture, which separates the application in three different components, namely the model representing the data, the view for handling the user interactions, and the template for rendering the web pages. By using Django, we can quickly and easily build web applications without having to worry about the underlying details. Django also provides a lot of functionality out of the box, such as the user authentication and authorization and database management. So in essence, Django is built on Python, and it leverages on the power of Python to provide a simple and efficient way to build web applications. We shall start this tutorial straight from the official Django documentation page, where there are three key takeaway points. Django is fast, secure, and it's scalable. Needless to say, this is a web framework for perfectionists with deadlines. And so this would be our workspace, and for now it's pretty empty, but in the next few minutes it will be filled with some interesting data. Django offers a very simple, intuitive, and verbose way to communicate with it. For example, to get started with the daily app, all we need to do is to write this command: the Django admin start app, name of the app, which is daily. And just like that, Django went ahead and created a daily folder, that is the daily app for us, with some other files in it. But for now, we will only be focusing on the models file. And now, think of these models as people. And just like people have different attributes such as the name, the age, gender, etc., models too have attributes like breed, the date of birth, etc. But instead of having name and age like people, models can have choices for certain attributes such as the hair color or the eye color. And just like people have choices for their favorite foods or hobbies. The choice for a person's favorite food can be pizza or tacos, and the choice for a breed can be Holstein or Jersey. And so, in a nutshell, models are like people, but with more specific attributes and choices, just like people, but with a twist of technology. And now, we shall start by writing the model classes, starting with the breed model. This will be the breed model, and for now we just pass because we haven't set anything of the attributes. We move forward to the cow model. The same, we just pass. And then we go to the milk model. And we pass. So this breed model stores the information about the breed, and then cow model stores information about the cows, and then milk model stores information about milk production, in our farm. And so I'll go ahead and pre-populate the attributes for all these models and explain them line by line. So I went ahead and pre-populated the models with several fields, and starting from this top part of the file, there are several functions and classes imported. For example, the minimum value data and the maximum value data, the validation error, the time zone. These are classes and functions that will help us validate and ensure that the data entered is correct and accurate and has no any errors. So let's start with the breed model. The breed model has only one attribute, the name model. the name attribute actually, and the name attribute will be a choice, actually a drop down list from this specific set of choices that I've set for now, that we will use the Frisian, the Ayrshire, the Jersey, the Crossbreed, and the Guernsey. Moving to the cow model, we have all these other several fields, and in these several fields there are some set of arguments. For example, there is this blank is equal to true. That means that that field is not mandatory, or the cow can be saved without a name. And then there is this max length that restricts the total length of the name to 64 characters. The breed attribute of the cow is a foreign key to the breed model, meaning that whenever a cow needs to be saved, it will only show the list of the already saved breeds in the database. Then the onDelete models.protect specifies that, or actually restricts that, whenever a cow is deleted, the breed that it was associated with remains in the database. Then there is the date of birth. That's an instance of the date field, and it gets validated based on the date that the cow is to be saved. For example, right now, the maximum value data that I had imported in the top of this file ensures that if the date that is passed as the cow date of birth, it's in future, or it's greater than today, it will throw an error, and this would be the message that it will throw to the user. The date of birth cannot be in the future. Similarly, the date of birth is just the same as the date of death. Also validates whenever date of death is keyed in, it should not be in the future, and if it is, it will throw out this error. The date of death cannot be in the future. And also, there is a difference between the date of death and the date of birth. That is the blank is equal to true. And as I had explained earlier, the blank is equal to true means that a cow would be saved without that field. And it only makes sense that whenever a cow is saved, you don't need to have the date of death when it is saved. Then moving forward to these other fields such as the sire, the dam, the calf, these ones too have the restriction of the deletion. This ensures that whenever this cow is deleted, the related cows, for example, who wants that whenever a calf is deleted, the father is also deleted? So it makes sense to restrict that when a cow is deleted from the database, all its relatives, I mean the father, the mother, and the other calves, doesn't get deleted. And by default, when a cow is saved, it does not require you to key all this. That's why there is the blank is equal to true for all of them. Then we have the gender where we will have a drop-down list of only two choices, the male and the female. And then we have the availability status, which is a choice field of the status choices. We have a tuples of tuples, and there are three tuples here. There's the first one where there's the A and the life, the D and the dead, the S and the sold. So Django works this way. For example, I've instructed it to default as A. This means that Django only understands the first value in these tuples. For example, A will means that Django will save the default availability status as live. And similarly, this applies to the pregnancy status that also has a choice field, and it defaults to N. And then we move forward to the tag number. The tag number is a property to this class, which means that it will be also accessed as an attribute, and actually it's just an attribute of this cow that is being saved, or this cow class, or this cow model, but it's only that it's being calculated automatically under the hood, and you don't need to key it in. So it works this way. The self.date of birth is a way of accessing the date of birth that has been keyed into this model or this class, and then we have the ID, which is automatically done by Django. And now this tag number attribute, or actually a property, returns something like this: the first two letters of the breed, the year of the birth, and then the counter ID. So this means that whenever a cow of maybe Frisian is saved into the database, and the Frisian is born today we are in 2023, it will take the first two FR in capital, and then appends and hyphen, then the 2023, then the counter. If it's the first cow, it will be appends a 1. And then also we have the parity as also an attribute that is being calculated automatically. In this parity, we access the number of calves that a specific cow is related to. This is the logic. Most of cows give birth to only a single calf, and so counting the number of calves related to a cow will give the number of times a cow has given birth, and so that is the parity. And then we have the age property. The age property is a dynamic attribute that cannot be defined or cannot be saved on the moment that we're saving a new cow, because the age of a cow today will not be the same as the age of a cow tomorrow, and not the same as the age of a cow in the next 3 months. And so I decided to write this code to calculate it automatically, and this is how it works. The age of the cow is calculated first of all in days. This will give a much more easier way to work with the age, because it's more robust. There are some instances where we validate the age based on months, years, and days. So calculating it based on days the first time is much more robust and will give us much more functionality. Like in this case, we check first of all if the age in days of the cow is less than 30, then what will return to the user as the age of the cow will be the cow is some several weeks or maybe some days old. Then if the age in days is less than 365, I understand that there are 366 days in some years, but well, we will use this 365 because 365 days is one full year. And so the logic here is whenever the age in days is less than 365, this means that the cow is just some months old and not it's less than a year old. We will calculate, or we will return the value based on the months and the weeks old. And then whenever the cow age in days is greater than 365, we will return a response of years, and the cow is years some months old. And then before we always save our model, Django has some methods and some restrictions, some validations that it does under the hood. One of them is this clean method. This clean method, or this clean function, is automatically run by Django whenever a new model is saved. Whenever a new model is saved, we will want to perform some validation checks. For example, we start with the age validation check. Nobody wants to have a cow older than 7 years in the farm because it's not even, first of all, productive. And so we access the cow age, then we divide by the 365. After dividing by the 365, we will get, remember this function, the get cow age, returns the age of the cow in days. So dividing by 365 flattens it to the age in years. So we check if the cow age is greater than 7 years, we will return a validation error and it won't save that cow. And also we perform some death status validation check, and if the availability status of the cow is set to D, then we don't have the date of death, it will throw an error, because it only makes sense that whenever a status of a cow is changed to D meaning that the cow is dead, the date of death has to be provided. This is just some validation check to ensure that everything is set in place. And also, if the availability status is set to D and the time that the date of death, the actual date of death that is keyed in is greater than 1 day, then it will throw this error, because any serious farmer won't allow any entry. And actually, it won't take any serious farmer more than 24 hours to realize that there is one cow missing, or maybe there's one cow that is dead in the farm. So it ensures that data is reported within 24 hours of death. And now we move to this validation, where we check if the cow is less than 21 months old, and we decide to set, or maybe somebody sets the pregnancy status as P, meaning that the cow is pregnant, then it will return this error. The cow must be 21 months or older to be set as pregnant, because it only makes sense that a cow matures after 1 year, and also it needs like 9 months to have its first calving. So the 12 plus the 9 makes it 21. And remember, the cow age was a function that we had in this model that was returning number of days. So we divide it by 12, then because it's number in days, so we divide it by 12 to get the value in months, and then we check against the 21 months here. And then we move forward. Similarly to this one, we also check if the cow is less than 21 months, and then remember the calf field, this one, where it's not actually required because we can save a cow without a calf. So this is a check to that field. If the cow is less than 21 months and the field is not none, the exclamation mark is equal sign is the syntax for Python programming to mean that not equal. So if the cow is less than 21 months old and the calf field has some data in it, then it will raise a validation error, because having that some data in it means that we have keyed in some calf, and assuming that maybe a calf is born today, it cannot have its calf because it's still young. Then there's also this another validation check. If the availability status is set to dead and the pregnancy status is not equal to not pregnant, it will raise a validation error, because there is no way we can have a dead cow in our database and at the same time that dead cow is pregnant. It only makes sense that any dead cow must have the status of not pregnant. And so let's move on to the milk model. The milk model has several attributes too: the milking time value, the date, the milking date, the cow, and the amount in kgs. Of all these, only these two, the cow and the amount in kgs, are all that will be needed to be manually entered. The rest will be done automatically under the hood. So the milking date is automatically logged in by Django, and this is the syntax. The auto now add true does everything for you and ensures that the time that milk record is saved is captured accurately. And so now let's move to these methods. This set milking time is a function that automatically ensures that whenever a milk record is saved, it checks onto the hour that milk record was saved, and then it sets the milking time value. So the milking time value will be set this way. Assuming that, for example, now it's 9:20 a.m. where I am right now, it will check. So 9:20 falls in between here. The hour is greater than 8, but also it's less than 1 p.m. So it will check. If it's that way, then it will now set the milking time value, this one, the milking time value to 2. And remember, the milking time value is the choice field, just as the breed and also the cow had the status choices, the choice field of the milking times. And the milking times is a tuple where we have the morning, mid-morning, evening, and night. So setting it to the milking time value of 1 means, no, milking time value of 2 for my time now, 9 a.m., means that this thing will now come and check that 2 means mid-morning, and it will automatically set it as mid-morning, because it will now take the data from the milking date. And that's how it works. And also for the milk model, there is this clean method that also is called whenever the model is saved, and we'll also do some checks. For example, we will check the availability status of the cow, because the cow is a foreign key to a milk model, and every milk record has to be tied to specific cow. And so the cow is a foreign key here, as you can see. So this is the thing. We check if the cow availability status is dead, and whenever the cow is already set to dead, it cannot accept any milk record entries. Similarly to the cow availability status to S, the S means that the cow was sold, actually stands for the sold, and you cannot have milk records for a sold cow. And also we check the age. If the cow is less than 21 months old, it cannot have any milk record, and this error that it will throw. And then this method, or this if statement and this try and except blocks, ensures that there is no double entry for a milk record for a cow at a very specific time. For example, right now, if we try to save a milk record for a cow named Peter, it will save for the first time. But if we try to save it again, just this very exact time before another milking time changes, then it will restrict, because you cannot have 2 milk records for the cow at the same milking time. I hope you understand the logic. And also, we check the cow gender. If the cow is not a female, and then there's no way male cows can produce milk. And lastly, we check on the amount of milk. So it only makes sense that for you to have a milk record entry, the amount of milk has to be greater than 0. And so if the amount in kgs is less than or equal to 0, then it raises a validation error. So this is how I've defined my models and the attributes. But there's one more thing remaining. So that we get everything pieced up together and running, we need to have a database. Django has a very simple way of doing this. All we need to do is to make the migrations. This implies that Django will automatically create a file for us that will instruct the system to create a database for us. And this is the file that is created on the fly, which is this, just by this single line, python manage.py make migrations. It will do this. And by the way, this thing is very intuitive. You can even read through it, as you can even now attest from all the stuff that we've done. This instructs the code to do this, migrations, create the model. The name of the model is the cow. This is now for the first model, then the fields are here. And by the way, if you remember, I talked of the tag number, where there's this ID thing. Let me just refer you back to where the tag number is. Yeah, you see, there is this counter that accesses this the ID attribute. And remember, we did not have any ID as an attribute to this cow model. So that's why I was saying that Django does it automatically for us. So it creates everything, as you can see. Then what it does, it instructs this thing now to make another new model, name the milk, and does everything for us. And so let's now get back to the terminal. So what we do after making the migrations, or like having the instructions for creating the database, what we need to do is also write another simple line of code, manage.py. Now actually migrate them, because in this first code it only creates the migration file, which is this one, and then now migrating them makes sure that now they are applied to the database. So if we do that, it applies them to the database just like that. And now, because now we have a database, we need to have a user who can log in and do the editing, the adding, the deletion, the updating of everything. So what we do to create a new user, we also run a simple command, python manage.py create a super user. A super user is somebody who will be able to have all admin privileges, like adding, editing, deleting, and doing everything in the database. So right now I will go ahead and key in my email address, peterevans1@gmail.com, then the password, some dummy figure there, then boom, the super user is successfully created. And so now we have a database that already can accept some data based on the models that we've defined. So what we do, we go ahead and now run the server. Similarly, just one line of code, python manage.py run server. And if we do so, boom, now we have a server that's running. Let me zoom it in a little bit. This is now our server. Just like that, we can now access our farm web page from here. If we click on it like this, now this is the default home page for the Django, but now we want to go to the admin to play around with the data. What we need to do is to log in, and this is one of the features that Django gives us for free. That's very handy, because you don't need to handle the authorization and the authentication of the user. It does everything for you. So we go ahead and log in, and as you can see, this is how the Django admin site looks like. Let me go ahead and this is how the Django admin site looks like. We already have the 3 models, the breed, the cows, and the milk already listed here. And what you can do, you can go ahead and add a new breed, Frisian. We save it, add another new breed, Ayrshire, save it, add a new breed, crossbreed, save it, another new one, Guernsey, we save it. And then now what you need to do is just to go back to these other models too and to play around with them too. We need to add a new cow, and now let's go ahead and add our first cow into the database. the first cow. Remember, I had defined this way. The name is not a required field, and that's why you get that it's great. But for these ones that are in bold, this means that they are required fields, and for a cow to be saved, they have to be pre-populated with some data. So let's just go ahead and save this cow with the name, the first cow. Give it a breed of the Ayrshire, and also now give it a date of birth of maybe, let's just go back a little bit, because we will also want to save a milk model. I think there is pretty far. Yeah, so let's give it this date of birth of 1st of April, and then there's this notification that informs me that I'm 3 hours ahead of time, of the server time. By default, when you install Django, maybe when you're starting to do the project, it works with the UTC time, the Greenwich or the GMT, the Greenwich Meridian time. So I'm 3 hours ahead of time, so that's not a very big problem. Remember, the sire, the dam, and the calf, all these are not required fields, but you can as well add the fields or maybe save some data in them. For example, right now we don't have any cow, and that means that you cannot get any drop down list, or maybe you cannot get list of any cows in the database. Or if you want to do so, you need to click the add, and then it will save the cow too. So what we do, we go to the gender. The gender is a required field. We save this cow as a female, and also the availability status is defaulted as alive, as I had told you when explaining the model. The pregnancy status is not pregnant. And now the date of death is a grayed out field because it's not required when saving a cow. So let's go ahead and save that cow. The first cow is saved successfully, and you can see we have this first cow, and then there's also this tag number. So the tag number is calculated based on the breed. And actually, let's go back and into this is the file that is responsible for the outlook of the admin. And as you can see, in the cow admin, we display the name, the tag number, and we don't have the breed. So let's add it to make it more robust. This is the breed. And yeah, so like that. So if we go back to our website and refresh it, now you can see this breed here. And as well, I think we need to add another property. We need to list age. Yeah, age of the cow too. Yeah, so we come here and list the age. So let's go back and refresh it. Wow, so for now you can see the age is calculated. This cow was born on 1st April, and that's from today it's 3 years and 10 months old. And now let's go to the last model, the milk model, and try saving some data. And as you can see, it only offers you the two fields, the cow and the amount in kgs. The others are done automatically under the hood, stuff like the milking time and everything. So now that we have only first cow in our database, it will only have that first cow as a drop down list. Clicking on it, and now let's just assume that we want to deliberately save a negative amount of milk in kgs. So if we try doing that, it will throw that error. The amount of milk cannot be less than 0 kgs. And also, no cow can produce more than 35 kilos of milk per milking session. And so if you try saving that, it will give this. So let me just show you where the restriction is. We go to the models, then the cow. Yeah, here it is. So the amount in kgs is an attribute to the milk model, and so what it does, it validates a minimum of 0. If it's less than 0, it throws this error that it had showed us, that the amount of milk cannot be less than 0 kgs. And then there's the maximum value data if it's more than 35, because this method works this way. It takes in the first argument as the value that it needs to validate, then the message or the error that it needs to yell at the user. So for example, I had deliberately set 40 kilos, so it will throw this error. The amount of milk cannot be more than 35 kilos. So now let's just try saving some valid value of maybe 20 kilos of milk. This cow must be pretty good producer of milk. So This is the thing. It will list the milking date, the milking time, and the cow. You remember I told you that the milking date is done automatically. As of today, it's February 15th. My time is 9 a.m. And you remember the message or the pop-up that I am 3 hours ahead of the server time. This is a new Django project, so it's still not configured on issues such as the date and all that stuff, but I will do them. This means that if we go back 3 hours from 9 a.m., we have the 6:41 a.m. And then this milking time too is calculated based on my definition of the hours. So assuming that now it's 6:41 a.m., it assigns us as milking done in the morning. Yeah, and so it also lists the cow. You can as well. So I also want to do another validation, or maybe just another check to confirm. If we give it another cow, second cow, breed of crossbreed, it's born today, it's a female, yeah, and the rest are just okay like that, and save it. And now we go to the milk. Remember, we've just added a new cow today, so this is a second cow and it's just born today, so I just want to deliberately try adding some milk record. Yeah, this cow is just still very young and it's just born today and it cannot have any milk record. But well, let's go back and yeah, you see it's 0 week old, 0 day old, because it's just born today. Let's edit this date of birth. Setting it to somewhere older than 21 months, but now changing the gender to be the male. So this is just to dynamically check if the cow is older than 21 months but is still a male, it won't still allow any milk record for milk cows. So this is the second cow, and let's try just saving it like that. Yeah, this is not a male cow and can produce more and cannot produce milk. And so for today, these are the 3 models that I've decided to define in this tutorial. I know this tutorial is pretty long, but I hope you enjoyed it, because the code and everything had just been like you conversing with somebody, and it's not those crazy computer codes and all that stuff, because everything is quite verbose and you can just read through the lines and read through the code in a sequential manner. And in my next tutorials, I'll be exploring more models responsible for this daily stuff, such as the symptom, the disease, there is the pregnancy model, the treatment model, the insemination model, etc. But just before I close this tutorial, I'd like to inform you that I'm open to suggestions, be it a new attribute that would want me to factor in the models, and maybe for the explanation of how something worked, just comment. And also you can write me to my email, peterevans1@gmail.com. And now, see you in the next tutorial. Thank you for watching up to this end. I hope you enjoyed it.